Good morning, guys. How's it going? So we're moving through our quadratic unit. So the first four topics were called quadratic functions, and now the second part is actually chapter 4 in the textbook. It's going to be called quadratic equations. Okay, so first topic is we're going to say solving quadratic equations graphically. I'll show you how that works. All right, so first of all, we're just going to start with a very simple question here. So 2x minus 1 equals 5, and how do we solve this question algebraically? Okay, so this is like more of a, I'm going to say a junior high style problem over here, but this is the kind of strategy we did. So when we say solve an equation, what we're trying to do is we're trying to figure out, well, what is this unknown value of x? Okay, so this is an equation over here. We have one equation with one unknown value, so we need to figure out what this unknown value is. So to do this, we're going to add 1 to both sides. I'm going to say 2x equals 6, and then for this is 2 times x. We're just going to divide by 2, and we have x equals 3. Okay, so simple enough. Now, the other way that we can solve this, I would never recommend that you solve this equation graphically because this is easy enough to do algebraically for you, but there is a way that we can solve it graphically, and here's how we do it. So we're going to use our graphing calculator. So hopefully most of you guys have the Texas Instrument calculators. And then if you have the Casio calculators or something else, this could be a very similar technique like that, but if you have a Casio calculator and you want me to kind of show you how to use those ones, let me know and I'll show you how to do those ones as well, okay? But the idea is we're going to graph two equations, okay? We're going to call this guy y1, and we're going to call this guy y2, okay? So I'm just going to open up my calculator program here. Okay, so to do that, if we ever want to graph something, we want to press this y equals buttons over here. And it's going to give us this screen here. So the first thing we're going to do, what we said with y1 was going to equal 2x minus 1. So I'm going to go 2, and the x button is here, 2x minus 1. And I'm going to go enter or press down. And I want y2 to equal 5. Okay, so once I have these guys inputted into my calculator, I can press graph. And I see these two lines over here. Okay, so I have my blue line is my 2x minus 1 function, and then y2 equals 5 is this horizontal red line over here. Okay, now what I want to be able to do over here is that these two graphs are intersecting here. Okay, now it appears that these guys are intersecting when x equals 3 and y equals 5. Okay, I'm just going to never mind, sorry guys. So we intersect of x equals 3 and y equals 5. Okay, so what I'm going to do is my calculator has a feature which allows me to figure out intersection points just to confirm this is exactly what it is. So if you see this calc button up here, so it's right above the trace button, we're going to go second, and then press the blue button calc over here, and we want to go down to number 5, intersect. So I'm going to press enter. Okay, the way to do this is first curve is this guy over here. First curve is y1, so I'm going to press enter. Okay, now it says second curve, y2 equals 5, enter as well. And we want to say guess, so press enter one more time. And what it says is we have x equals 3, y equals 5. Okay, now the thing over here is we really don't care about this y equals 5 part, okay, because the unknown variable in our equation was x. Okay, it was x equals 3. So we don't really care about this y equals 5. So solving this one graphically, we want the x value of the intersection point. We get x equals 3. Okay, so I'm just going to quickly do a little sketch of this guy over here. 2x minus 1 looked like this. Y equals 5 looked like this. This intersection point was 3, 5. And then x equals 3 is the solution. Okay, so we want the x value of the intersection point. Okay, and that's going to be the solution to an equation graphically. All right. Okay, so for example 2, we have x squared minus 4x minus 5 equals 0. For the start of this unit, guys, we're going to teach you some techniques on how to solve these guys algebraically. And here's the problem. Well, based on what I did in the last example, my strategy was add 1 and then divide by 2, and that's how I got x by itself for this equation over here. Unfortunately, it's not going to work this way. Okay? Like if I add 5 to both sides like this, I get x squared minus 4x equals 5. Well, what would my next step be? I thought it would be to square root both sides, but like that kind of well, that's actually really not going to do anything for us over here. Unfortunately, it's just not going to work by doing this over here, right? So unfortunately, guys, kind of like trying to isolate for x in the traditional way is not going to work for these type of questions. Okay, we kind of run into this problem over here. Okay, so we have two other techniques which we're going to learn in the next topics of this unit over here. So really, guys, we are not equipped to be able to solve this question algebraically yet. Okay, so we have to solve it called by factoring or using a quadratic formula, and I'll show you how to do that one later on. So right now, all we're going to do is we're going to solve this one graphically. Okay, so I'm going to call this guy over here my y1, and I'm going to call this guy y2. Okay, so I'm going to go back to my calculator and y equals, and I'm going to clear out what we have in here. And we have x squared minus 4x minus 5. There's y1, and y2 equals 0. We're going to graph that. So what you can see here is like my red line is y equals 0. You know, I have this blue curve, this blue parabola over here, and we have our for two intersection points. So it looks like -1 is going to be an intersection point and +5. Confirming that, I'm going to go to press my intersection button, and then second calc intersect. Okay, first curve, second curve, guess, yeah, and I sure do get -1, right? So -1, 0. Again, we do not care about this y equals 0. We only want the x equals -1 part. Okay. To figure out the second intersection point, I'm going to press my intersection button again. But this time, with my right arrow, I'm going to scroll close to this intersection point over here. So now my cursor is close to this intersection point here. Enter, 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 and I get 5. Okay, so my two solutions are x equals -1 and x equals 5. All right, so we're going to see our solutions like this. All right, same idea over here. Solve this one graphically. We're going to go y1, y2. Okay, so I'm going to go and clear what's in here. There's my y1, and my y2 is y2 equals 0. Graph. Okay, so over here, I can't quite see this second intersection. It looks like it's going to be exactly x equals 10, but what I'm just going to do, I'm just going to expand my window just a little bit. So I'm going to make my x max a bit bigger. I'm going to go 15. And I'm also going to make my y min a bit smaller actually as well. I don't really need to do this over here, but it just it's going to kind of, I can see more of the graph like this, so I can kind of see, I can almost see the bottom over here. But now, so I have my intersection point here and my intersection point here. So we go second calc, intersect, enter, enter, enter. We get x equals -1. Second calc, intersect, scroll with my right cursor close to my second intersection point, and I get x equals 10. Okay, so I get -1 and 10. Put this one over here. Okay, and example 3. 3x squared minus 2x plus 1 equals 2x squared plus x plus 5. Okay, now in this case, I'm going to show that there's two methods to solving this one graphically here. So what's different right here is just that there's two sides to equal sign, and the other two examples I did, it was always equal to 0. So for method 1, I'm just going to make one side equal to 0. So I'm just going to subtract 2x squared from both sides. I'm going to subtract x from both sides, and I'm going to subtract 5 from both sides. And what that gives me is x squared minus 3x minus 4 equals 0. And now I'm just going to go y1, y2, intersection point here and here. So we have x equals 4 is one solution, x equals -1. Okay, so we get, my solutions are x equals 4 and x equals -1. All right, here's method 2. So method 2 is, I'm going to say, just exactly the same that we did in the other one, but instead of setting one side equal to 0, I'm just going to go with all this stuff as y1 and all these guys as y2. So I'm just going to go back, and the idea is, like, since these equations are equivalent, they should be giving us the same answers. Oops. So when I do this, we get 3x squared minus 2x plus 1. Sorry, plus 1. And we have 2x squared plus x plus 5. 2x squared plus x plus 5. Okay, so when we look at these guys over here, now I'm going to press graph. Okay, and the point is, well, I have one intersection point right here. Okay, so if I go second calc intersect, and I'm going to scroll with my cursor until I'm close to this intersection point over here, enter, 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 and I get x equals -1. So again, guys, we don't care about this y value over here. We only care about the x value of the intersection point. So even though we got a y equals 6, this is not part of our solution, only the x equals -1. Now the other one I can't quite see. It looks like I need to have a bigger y max here. So I'm going to go window y max, and I'm just going to make this guy 50. Graph it again. So now I can see this intersection point over here. So I'm going to go second calc intersect. I'm going to scroll up over here, enter, 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 and I get x equals 4. Again, we don't care about this 41. It's not part of our solution. It's only the x value of the intersection point that we want for part of our solution here. Okay, so either way, I still get these same solutions over here due to method 2. Like this. Personally, I think this is the easier way to do it. Okay, set one side equal to 0. And then really you're looking for the x-intercepts of this first function over here. Is going to end up being your two solutions to this question over here, okay? But this is how this works. All right, guys, I hope this gives you a good little intro to solving equations graphically, and I will see you in the next video.